Hi everyone, in today's podcast we'll be talking about our assignment, which is calculation using past software. Let's get started for case study 1. As usual, I will start our podcast with introduction for case study 1. Ecosystem depend on biodiversity, which is crucial for research, conservation, and resource management. Result assessment technique use diverse indices like Channel-Wiener Index, Simpson Index, and evenness to understand diversity. Past software is used to compute these indices, providing a graphical user interface for multivariate analysis and trend presentation. This case study demonstrates the practical use of PAST 5.0 software in biodiversity analysis, including data preparation, formatting, input, and diversity indices calculation.
Then I would like to talk about the result. We put the data of case study 1 into the past software, and this is the result of the diversity indices and compute indices like Channel-Wiener, Simpson, evenness, and more. Next is the scatter plot, which is site 1 is lower than site 2 and 3. Lastly is the bar plot. It shows abundance for site 2 is higher than abundance for site 1 and 3.
Well, based on the result, we discussed that Site 1 has low taxa count and low diversity compared to Site 2 and 3, which have higher richness and diversity levels. Site 1 has more species dispersal than Site 2 and 3, with the highest Simpson diversity index. The distribution of species diversity and density may be due to environmental condition or human influence.
Biodiversity analysis using PAST 5.0 reveals significant differences among three study sites in terms of species richness, evenness, and overall diversity. Site 1 had lower species richness and diversity, while Site 2 and 3 exhibit higher species richness and diversity. Despite this, Site 1 showed better evenness, indicating a more balanced distribution of fewer species. Site 3 had the highest Simpson diversity index, suggesting a more varied and resilient ecosystem. This biodiversity variance stem from differing environmental conditions or human influence. Graphical tools like dendrogram and scatter plots help visualize this ecological pattern.
Then, we will move to talk about our second case study, which is focused on analyzing animal diversity. Biodiversity is very important because it helps keep ecosystems balanced and healthy. It also shows how different species live together and how many of them are found in certain areas. In this case study, we are analyzing the diversity of animals in 3 different locations. To measure biodiversity, we use tools like Channel-Wiener Index, Simpson Diversity Index, and evenness. These indices help us understand how many species are present and how evenly they are distributed, and whether one species is dominating.
Now, I will talk about the result for the case 2, which is this is the table of fauna diversity of each species for Site 1, Site 2, and Site 3. There are several species like Canis lupus, Vulpes, Lynx, Ursus arctos, and Felis catus. Now, this is the table for the diversity indices like Channel-Wiener, Simpson, evenness, and others for the each species that are available in Site 1, Site 2, and Site 3. This is the bar chart for the species abundance for each site, which is for the Site 1, Site 2, and Site 3. This is the scatter plot for the each species that are available in each site like Felis catus, Vulpes, Ursus arctos, Lynx, and Canis lupus. This is the dendrogram for cluster analysis of each species in the each site like Felis catus, Canis lupus, Vulpes, Lynx, and Ursus arctos.
So let's go to the discussion and find out more about result. As we can see, for the bar chart for species abundance, have 3 different locations is shown in the bar chart. Site 3 has the highest abundance, about 0.8, while Site 2 has the lowest abundance with a value of 0.35, while Site 1 has an average level of abundance about 0.6. This means that Site 3 maybe offer higher resources and condition, and it making more suitable habitat for a variety species. For the scatter plot, is a visualization tool. It can show relationship between a species and a site. Species closer together are more similar, while the farther apart are less. So for the line from the origin to species label can show their influence on the site data. For example, site 1 is strongly influenced by Vulpes vulpes and site 2 by Felis catus. This provide a visual summary of the ecological connection between the species and site.
The Simpson index for site 1 and 2 reached the 0.7 marks, which is 0.7405 and 0.7109 respectively. For site 3, the Simpson index for them is 0.678 and 82. This means that the site 1 is the most diverse, followed by site 2 and 3. For Shannon index for site 1 is 1.452. As for site 2, it is 1.401, and the value for site 3 is 1.253. The higher the number, the greater the diversity, meaning the community is more evenly distributed among the species. By looking at site 3, we can judge that the Shannon index value is lower than the rest because of the high number of Canis lupus in the sites, thus making the value lower. For evenness index, site 1 show the value of 0.8544, which make it indicating that the community has a fairly equal distribution of individual among species. For site 2, the value is 0.8122 and 0.8752 for site 3. The evenness for site 3 could be due to the amount of species available in the site, which have 4 species, compared to other site, which is site 1 and site 2, which have 5 different species. The value of evenness index is all quite the same all across the site. Higher value of the evenness index show that individuals are evenly distributed among species in the community.
And finally, as always, I would like to conclude that the reverse J-curve pattern illustrates the healthy forest growth, such with a high density of small diameter tree, indicating strong recruitment and early growth, essential for the forest regeneration. The steep decline in the tree number with the increased DBH reflect natural competition and environmental challenge that shape the ecosystem. However, the subsequent rise in the tree number in larger DBH class highlight the adaptation and survival of certain species under the favorable conditions. And these structures support biodiversity, carbon storage, and ecosystem service. The effective forest management, including the selective logging, thinning, and regular monitoring, is crucial to maintaining a balance between young and mature tree population, ensuring the forest sustainability and ecological health over the time. Thank you for listening.